All right, we're back. We're on page 3 of note 17 of Calc C. We're talking about polar coordinates. And so far, we haven't done any calculus. And I kind of feel like Calc BC assumes you walk in not knowing any polar, which is not the case if you took math analysis. But if you didn't take math analysis, this might be an intro to polar for you. I recommend your intro to polar be the math analysis notes. Like, if you're watching this on the internet, just go find them. It's math analysis. Note 16, same place you're watching this video, you can find a playlist of me doing all of those notes. That'll prepare you really well for all of this stuff. This is review, so I'm treating it like review. So I'm going kind of quickly, I think. So in the last video, we ended with a box of things. And in the box of things, you got circles, you've got some vertical lines, horizontal lines, lines through the origin, circles tangent to the origin. All of those you should know and recognize. Because if you know and recognize them, things go really quickly and you don't have to like spend any mental effort on them. If you don't recognize something or you forget, the easiest way by far to graph a polar curve is to first graph the rectangular function and then turn it into the polar graph. That's by far the easiest way to graph. And when in doubt, just do that. In fact, a lot of the calculus of polar curves can be done just by looking at the rectangular graph of the trig functions, or the polar curve, I guess, whatever. So keep that in mind. Anytime you get a little bit lost, think to yourself, like, if this wasn't polar, if this was just rectangular, what would be happening? And you can often use that to answer your questions. A very, very weird thing is that the slope of I don't know if it's actually a weird thing or not, but like, keep in mind your polar coordinate grid, right? All your concentric circles actually just lives in the XY plane. And since it lives in the XY plane, when we talk about the slope of the tangent to a polar curve, it's going to be in terms of X and Y. That to me is like a really weird thing initially, but I guess it's not. So that's one of the things we're going to have to deal with. And maybe you also think it's strange to begin with. Graph these circles, note the interval for which the circle is traced out. All right, so I don't know. This should not really take forever. Except if the lines don't form. Do it. Be a line. Okay. And then instead of wasting our time on the next one, let me just duplicate that right now. Okay, so radius is 3. Radius is 3. So here's 3. I would start here at t equals 0 or theta equals 0. And then go this way. Become a circle. So I'm here at theta equals 0. I'm here at theta equals pi over 2. I'm here at theta equals pi. I'm here at theta equals 3 pi over 2. And then I'm back here at theta equals 2 pi. So this takes 2 pi to trace out. That's going to be important. It's really important to know how long it takes a polar curve. And it's also really important to know like where you are on certain intervals. So like between pi over 2 and pi, I know that this is where I am for this particular circle. You want to know that so that when I ask you a calculus question, you'll know where to look on the curve. Figure out what's going on. Here, we have r equals -5. So think it through. When theta is 0, so when theta is 0, you're facing this way, r is -5. So instead of walking out 5, you walk backwards 5. So you actually are going to be here when theta equals 0. You're at -5. And then let me draw a circle. Do it. Become what you're meant to be. The key to making it work is to not like actually get it to work. I don't really know what I mean by that, but that's the key. This looks terrible. Why is that? I guess because I got the radius wrong. I don't know, whatever. You're here at theta equals 0, and then you rotate counterclockwise. Like life goes counterclockwise in math, so you're here at pi over 2, you're here at pi, you're here at 3 pi over 2. And so think about it, like when you're facing 3 pi over 2, you're facing this way, but r is negative, so you're here. So it makes sense that that's where you'd be. And then you finish off at 2 pi. So this also takes 2 pi. So these are your basic circles. They are centered at the origin, and they take 2 pi. So centered at the origin, take 2 pi. You want to go counterclockwise, like calculus basically, all of math wants to go counterclockwise. So let's graph these. So these are tangent to the origin, centered on one of the axes. So for example, here, it's positive sine, so it's going to be centered on the positive y-axis. The diameter is 2, so I'm going to get this, I guess. So the center is going to be 0, 1, and then the radius obviously is 1. I guess I should write radius. It's weird because you want to abbreviate radius, but if r is equal to some polar curve, then you shouldn't really also say r is equal to 1. Now, how does this relate to the rectangular graph? Let's take a look. So 2 pi, what is this? 2 sine. So we'll go up to 2, we'll go down to -2. Pi over 2. So I'm assuming that you have reviewed your analysis notes. I'm assuming that graphing polar is something that's pretty fresh in your memory. So this is a quick review. Here to here to here. So look what just happened. You started out at what is this? This is theta, this is r. Okay, when theta is 0, r is 0. So we're there. When theta is pi over 2, r is equal to 2. So we're going to be here. Also, I never graphed the curve. Okay, so when theta is pi over 4, you actually end up here, kind of like by symmetry. You can work out what that point is. Oh no, actually, you know what that point is. Do you know what that point is? So r is equal to 1. So why is that 1? Why is that working the way it is? That's 1, 1, right? You're 1 away and you're 1 up. And so is that at pi over 4? That's not at pi over. That's not where you are at pi over 4. I don't think. Pi over 4, you would be at, golly, what am I even doing? Okay, so what do I want to do here? Pi over 4. R of pi over 4. This is because I confused myself. It'd be 2 times the sine of pi over 4 is root 2 over 2. So root 2. Then you're pi over 4 away. Oh, yeah. Wow, okay. So then x is r, and then the cosine of pi over 4 is root 2 over 2, which is 1. This is me confusing myself. And then y is going to be r sine of pi over 4 is root 2 over 2. It's 1. So you are there at pi over 4. Like, it made sense that you were there, but like all of a sudden I had confused myself quite a bit. So you're here at pi over 4. You're here at pi over 2. So at 3 pi over 4, you're going to be here. And then at pi, you're going to be here. This only takes pi to trace out. And you'll find that's the case with all of the circles that are tangent to the origin centered on one of the coordinate axes. So like here, here's 5. I think the best thing to do though is just graph these. Oh God. It's like you know that no one wanted what you gave it. There we go. I can't imagine anyone would ever want that. There's 5 halves. So the center is going to be at 5 halves 0, which I'm drawing right on my face. And then the radius is going to be 5 halves. And it's going to take pi. So if you're centered on one of the axes, tangent to the origin, it's going to take pi. Here, so -4, and it's sine, so it'll be on the negative y-axis. And we just kind of like go for it. Come on, nobody wants that as their circle. Yeah, that's weird. The key thing is like, don't get it too good. If it's too good, it won't do it. So here's -2. So this is centered at 0, -2. And the radius is going to be 2. Now, where are you and when? So for this, it's a little bit different. So let's graph it in rectangular, theta and r. So it's -4 sine. So it's going to go 4, -4, 2 pi over 2, 3 pi over 2. Okay. 0, you're here, then here, then here. So you get this. Okay, so when theta is 0, r is equal to 0. Boom, boom. When theta is pi over 2, r is equal to -4. So you are here at pi over 2. Now, which way did you go? Did you go this way or did you go this way? Well, think about it. You're rotating this way. The only thing you can do while rotating this way is either walk forward and end up in the first quadrant, or while you rotate this way, you could walk backwards and end up in the third quadrant. So actually, you start here, you get here at pi over 4, you will get here at 3 pi over 4, and you're going to take pi to do the entire thing. Once you hit pi, you just start tracing it over again. You don't want to do that because that doubles the area, it doubles the circumference, doubles everything, and we don't want to double things. All right, let's try this last one. I'm assuming -12. I don't know why I'm trying to draw them like roughly to scale, even though good circle. It's making my axes look obviously terrible. I don't know. All right, so center here, center, -6, 0. So like, what does this have to do with calculus? You can't do the calculus if you don't know this stuff. Let's start there. And then this takes pi, because as I've mentioned, maybe in this video, maybe in a previous video, I think they just assume you don't know any polar going into this. So you have to like make sure you have the basics down. And once you have the basics down, you can do like almost anything. Where are you and when on this one? You might ask. So at theta equals 0, the cosine of 0 is 1. So you're actually at -12. This is where you start. So you start here at t equals 0. Now you're rotating. So the key thing is like rotating, and what quadrant can you be in? When you're rotating through quadrant 1, you can either be in quadrant 1 if your r's are positive, or you can be in quadrant 3. So this, as we graph it, actually you will be here at theta, I guess, is pi over 4. You'll be here at theta equals pi over 2 because the cosine of pi over 2 is 0, so you just 0, 0. You'll be here at theta equals 3 pi over 4. And let me embarrass myself again and try to figure out the ordered pair at 3 pi over 4, right? So it should be r of 3 pi over 4, and then cosine of 3 pi over 4. And then y should be r of 3 pi over 4, sine of 3 pi over 4. So this shouldn't be that bad because of the 3 pi over 4s. So r is going to be, the cosine of 3 pi over 4 is -√2/2. So this will be, whoops, you're not a pen. This will be -6√2 times, the cosine is √2/2, which gives me -6. And then this, the sine of 3 pi over 4 is √2/2. So -12 is -6√2/2. What? No, what? I said I was going to embarrass myself. The sine, what am I doing? Oh, when you just plug 3 pi over 4 in, you're doing, oh my God, you're doing the cosine of 3 pi over 4 is -√2/2 times this gives me, did I get this wrong before? I did. I would like to take a do-over on the x coordinate where I'm confident I said something wrong. So r of 3 pi over 4, r of 3 pi over 4, oh my God, is -12 times cosine of 3 pi over 4. Cosine of 3 pi over 4 is negative. So r is positive 6√2. So this should be positive 6√2. And then you're going to multiply that by the cosine of 3 pi over 4. The cosine of 3 pi over 4 is negative. And so you still get -6, but like it's really important to, you know, have correct work. So here, that's good. I psyched myself into that by saying like, now I'm going to embarrass myself. So I get this. So the ordered pair is -6, 6, which made sense because I knew it ahead of time. This is part of the advantage of knowing ahead of time where you are. You don't have to go through all these embarrassing errors. So anyway, little bit of review. I will be back in the next one to, I think, do some more review, but with rose curve. So if you want to just watch some rose curve videos, I would recommend that. Otherwise, come back and watch me do it, and I will see you in the next video.